All right, students. So let's talk about this Heartburn Lab. So I've got some of this set up here. And we're going to go through the whole procedure. There's a lot of stuff I want to talk about, but let's just dive right in. So the idea behind this lab is to figure out antacids. So this is a container of peppermint flavored. I chose these specifically because they are white. If you get colored ones, it can interfere with the indicator. What we're going to do is we're going to add this to some hydrochloric acid. So hydrochloric acid is what is in your stomach. The concentration is somewhere between 0.03 and 0.0003 molar. I'm going to use a far more concentrated version. This is 0.1 molar. Just that way we don't have to use quite the volume. It's also what I happen to have on hand and I don't feel like diluting it, so I'm not going to. So what we're going to do is we're going to add quite a bit of this acid and one of these antacid tablets. What should happen is it will not neutralize all of the acid, but it's going to neutralize quite a bit of it. Then what we'll do is we're going to titrate whatever's left using a burette, and we're going to titrate it with some sodium hydroxide to figure out how much acid was left over. And if we know how much we started with, we know how much was left over, we should be able to figure out how much was neutralized. So I've got quite a lot of equipment and procedure to go over with you all, but we're going to get through all of it. Before we get into that, the reason that we are able to do this lab and make it work is because of phenolphthalein. So phenolphthalein, for you all, we often store it in these little droppers because you only really need a small amount. You can see a little bit of liquid in there. It's dissolved in either water or alcohol. It actually is not super water soluble. It's not bad, but it dissolves in alcohol really well too. Anyway, phenolphthalein, it's a weird word, it's a weird spelling. It changes color based upon if it's in an acid or base. So actually, I want to show you, I just went to Wikipedia, which can be a reliable resource. It isn't always, I wouldn't cite it, but in this case, it's a great resource. So phenolphthalein, this is its chemical structure. So for AP kids, this has a lot of double bonds in it, which is pretty cool. There it is, this little powder. There is a really good animation here. We'll get that started in just a moment. Here's a quick summary of what color it turns depending on the pH. So hold on a second, I'm gonna turn this other light on. Use a little bit more light on here. Might be helpful. Okay, that's slightly better. All right, so IN in this case refers to the indicator, which is phenolphthalein. If you look back here, it's got this crazy name. You can see it there, phenolphthalein. Took me about 3 years to learn how to spell it. And depending on whether it is how much, what type of, if it's in an acid or a base, it will change color. So in a really strong acid, when the pH is really, really, really low, less than -1, that's super, 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 super acidic. High, very, very, very high concentration of hydrogen ions. Hydrogen ions will be all over the place on this, and it has a particular shape. When it does that, it turns into this orange color. I actually have a little bit here. This is 16 molar sulfuric acid. So this is sealed up really tightly because if we open this, it will smell super bad and it's really dangerous if you poured it on yourself. But phenolphthalein is indeed this kind of orange color. Once you start raising the pH, lowering the hydrogen ion concentration, the shape changes again. Once it's kind of more basic, it turns pink. And then if it's really basic, if there's a very little hydrogen ion, lots of hydroxide, it actually goes back to being clear. So this animation is pretty great. Hold on, I'll show it to you. And it kind of shows the conformation changes. There it is. So for AP kids, you'll remember this is a good example of resonance. So all of these bonds moving back and forth, it's an example of resonance. So this is showing how, yeah, once you add this to water, it becomes kind of clear. Here we've got some hydroxide taking away some of the hydrogens. This is as the pH is rising. It's kind of showing the process. and the conformational changes. It's pretty cool. This is good, like if you were, if this kind of stuff is cool to you or looks interesting, this is very much in the field of organic chemistry. Okay, so it starts to turn pink when there's enough hydroxide removing some of those hydrogen, the protons, from the actual phenolphthalein itself. So phenolphthalein is essentially, it can be an acid or a base. It can accept or it can donate hydrogen ions. We want this to turn pink. It just starts to turn pink. Some of the molecules will start to turn pink at pH 7. They won't all be pink at pH 7. You have to get to pH 8 to 10 for it to all be pink. So if the solution is completely pink, like a darker pink, you know that you've gone too far because you've just added too much hydroxide. If you just have a small amount, like at pH 7 when you've added hydroxide, a light pink indicates that some of the phenolphthalein has converted to that form, but not all of it. And it's kind of like more that equilibrium, like kind of sweet spot that we're looking for. So that is phenolphthalein. I think that's what you need to know about it. And I think you'll be able to see that in our lab. It's pink. We need it to turn pink. That's why I chose an antacid tablet that doesn't have a color to it. Sometimes they are pink or orange, and I'm like, well, that's not going to help us if we're looking for something that we need to see a color change of pink. Okay, so let's take a quick look at the lab itself. I'll kind of explain it as we go. Your lab sheet should look like this. Okay, so this is a little description about all of that. So for this lab, our purpose again is to determine the amount of acid neutralized by an antacid. Materials and procedure, I'm going to start kind of going through that as I set up this lab and explain all of the parts to it. So you can write those out somewhere. We are going to need a data table, and this is all the data that we're going to collect. And I think I'll be able to show that to you as we go. So I think it might be time just to dive straight in and let me show you all the parts and how we're going to do this. All right. So for setup, get up in here so you guys can see all of this. The first thing that we're going to need to do, we've got our base, which is our sodium hydroxide, and our acid. I am going to measure out, so you guys can see all of the equipment. I think the first thing I want to do is I'm going to use these pH papers just to show you an acid versus a base. There's pH meters as well, but I'm just going to use these papers. And these papers are going to turn different colors, so we'll be able to figure out what, if we're dealing with acid or base. So this is the sodium hydroxide. I'm just going to I just touched it to the lip, and you can see it is blue. You guys can kind of see that. It's quite blue, which according to our pH papers means that we are definitely dealing with something of a pH of 12, which is quite basic. This is at least 11 or 12. So that is indeed a base, and it's definitely going to work. I believe that that's sodium hydroxide. And let's check out the acid. So this is the hydrochloric acid. Again, I just kind of shook it up so I could get a little bit on the paper. Yep, and you can see that that is quite pink, which is definitely an acid. So far so good. It's always good to check these things. Make sure we're not dealing with something weird. So I think for this lab, I'm going to go for about 20 milliliters of hydrochloric acid. I think that sounds like a reasonable amount. So I've got a graduated cylinder, and I'm going to fill it up to about 20, and I'm going to write down the exact value and make sure, yep, I've got a pen ready to go or a pencil. So let's pour this carefully. Graduated cylinder, you can hear that lovely noise right about there. And I'm going to read exactly what I see. So yeah, you'll be able to see there's the bubble with the meniscus. If I put this here, you might actually be able to, can you see it? Not really. Okay. Cameras. Yeah, I have to put it down on a flat surface. So hold on, let me get this reading. Okay, it's not quite 20 milliliters. It is like 19 point. I'm going to go with like 19.7. So that's what I'm going to write down. It does not matter. Makes no difference. So I'll show you the lab sheet as I'm filling all this information in. Okay, so that's our hydrochloric acid. This represents our stomach acid. The next thing we're going to do is we're going to take an antacid tablet and we're going to crush it up. It looks like it's been divided in half. I'll use a whole one. So I'm going to take 2 halves. It's pretty much a whole. And what I'm going to do here is crush these up with a mortar and pestle. So mortar is the bottom part, pestle is that part. So we're just going to kind of crush them up. You can use this similar thing. People use it for grinding up spices. I know in Spanish it's called a molcajete. Okay, so that is our, I turn it into a powder just because that way it's a lot easier and it will react very quickly. Reaction rates, we'll get there eventually. Now, normally I would put this in an Erlenmeyer flask because it's really good for swirling. Titrations are best done with Erlenmeyer flasks. However, I have to get this powder in here and I just don't really see that working well. So I'm going to use just a beaker instead. So we're going to dump all of that. It's got a little spout. I didn't quite get all of it, but it'll be fine. And now I'm going to pour the acid in. And we're just going to give it a stir. It's foaming up a lot. I think that's a combination of the actual reaction, the neutralization happening. It's not really changing temperature. There are also like stabilizers and other chemicals, other types of like inactive ingredients that are going to make this kind of thick and weird. Okay, so that looks pretty good to me. Oh, I do have a rinse bottle. Grab that real quick. I'm gonna just rinse off the end of my stir rod with this, and because I am adding water to it, but it's not going to affect our calculations because we know how much acid we started with. So normally adding volume would be a problem, but not in this particular case. Okay. So the next thing I want to do before I move on is I want to make sure and see if this is still acidic or not. If it's not acidic, we're going to have to try it again. So, I think it got neutralized too much. Okay, cool. So let's try again. Let's see, maybe instead of, let's just add a half of a tablet next time. And I'm gonna add a little bit more acid. Let's do like 40 milliliters instead. All right, so let me grab a new beaker. One moment. This one might be okay. Okay, lab design, y'all. This is how it works. Okay, so let's measure out. I'm gonna measure out 40 milliliters this time, approximately. We'll just double the amount. It should be good. That's close enough. The actual amount is 30. Oh gosh, that's pretty gosh darn close. 35, 36, 37. Looks like 38.0 actually. We'll make an adjustment here. 38.0. Okay. And we will crush up, it's time to tap a tablet. So yeah, basically what happened there was, that's an experimental design issue where this lab requires that the acid is not completely neutralized, it's only partially neutralized. So yeah, that did not work. So we'll try this. I bet you it'll work this time because we've doubled the volume, the amount of acid added. So we've doubled the moles essentially, or close to. and we cut the base in half. So Tums tablets or various antacids, these are off-brand, they're not brand name Tums, use calcium carbonate, which acts like a base, but it's not a strong base. So measuring it directly would be kind of tricky. So let's try this now. We are still red, so we are still good to go. So now we should be able to get a decent reading. Okay, so this is going to get transferred over to my burette. And now we need to move on to burette setup. So far we've used various pieces of equipment. We're moving on to the burette. All right, I'm going to add a couple of drops of phenolphthalein in here. It should be clear. It shouldn't change the color at all. You only really need a few drops. I've added way more than I need, but there it is. I'm just going to give that a quick swirl. Okay, now we need to fill up the burette. So burettes are measured. This one has the capacity of 50 milliliters, and it measures it very precisely. So the first thing that we need to do is we need to fill it. And to fill it safely, I don't want to pour like base way up here, the camera, because it's way above my head. And if it spills all over my face, that's bad. I don't want that. No base on my face. Not into that. That is a way to get it. That's a recipe for a chemical burn. So instead, I'm going to put the burette up to the edge of the table and then just lower it until it is at a safer distance, more like eye level. And there we go. I'm pretty tall, so eye level's pretty high up for me. Put a funnel in. One thing to make sure is that the stopcock is closed. So that's the little stopcock at the bottom. If it's parallel like that, it's closed. And I'm just going to pour this is my acid. Don't do that. Pour our base. Now, our base has a concentration of 0.135. Yeah. So I'm going to pour in, I think about 50 milliliters. Just pouring it in kind of carefully. It fills up faster than you think. Here we go. Whoop. Oh, okay, I didn't overfill. Okay, thank goodness. Okay, so it's kind of hard to see. Let's see if I can move it. It's filled up. The 50 millimeter line is here, and we're all the way up here. So I'm going to need to drain off a small amount. So I'm going to do that. We're ready now. And it's really important to record the starting volume so you can subtract it out later. So to use this, I just turn the stopcock and the liquid comes pouring out. And we're going to stop it right there. So that's just some sodium hydroxide. All right, and lower this down a bit. You know what, actually, I like this base is kind of white porcelain, which is going to be really nice because it should be turning a pink color, and that'll help us see it. So we're going to lower this in. And basically, essentially what we're going to do here is we're going to keep adding sodium hydroxide until it starts to turn just a little bit pink. My starting volume is, I'm going to take a picture. Let's see where I put where's my phone? There it is. I'll take a picture so you all can see this. Let's see. So you can see how I got this number. Will this work? Not too bad. See if I can get to focus properly. Okay. So the starting value, you look under the meniscus, and we should have 2 places past the decimal because of how precise this piece of equipment is. That looks like to me, we are looking at 0.5, 6, 7, 8, 0. I'm going to go with like 8.9 is our starting volume. And yeah, so that should give us plenty of significant figures. Okay, so now we just kind of open this up and start adding and see how it goes. At first, not much is going to happen. It's just filling up this beaker. I may have to switch this to another beaker. This might be too much volume. Okay, I'll stop and just kind of swirl it gently. So far to me, it still looks quite clear, kind of this slightly hazy kind of color. It looks like I've added about 19 milliliters. I'm expecting probably to have to add almost double that. We'll find out. So, ooh, I think it's hard to tell. I thought I could swear I saw some slight pink forming. Let's see if we can't get a slightly, yeah. Oh man, you guys are seeing it. Let's see if we can see if you'll notice it. Now, so far it's still pretty clear. I'm starting to see a little bit of pink there, which is kind of how I know that we're near the end. Once you think you're getting closer to the end, it's good to slow down a bit. Yeah, there's definitely some pink in there. You can kind of see it's very, very faint pink. Absolutely, just a tiniest bit, maybe. Might be hard to see. Yeah, I'm even seeing it now. So I'm just going to add a tiny bit more. Just go drop by drop. Okay, there's definitely some pink. Let's see if it goes away. Maybe you all can see the pink now. Maybe a little bit. I'll take a picture. I think it's fading out. So this will happen. It'll kind of turn pink and then it'll go back to clear. So I don't think we've reached that point yet. Oh, I think we're getting kind of close. Ooh, that's quite pink. Okay, here, I'll show you. I think you all can probably see. It's definitely a bit pink. I'll take a picture. And that's kind of the color we're looking for. This particular lab makes it a little difficult because there's a lot of other stuff in this beaker. If it's just, yeah, I'm gonna say that's pretty good. Oops, sloshing all over. That's not very safe. Should have used a bigger beaker. Okay. So it is pink and it is staying pink. Again, hopefully you guys can see that very faint pink color. I'm gonna write down the number I see and I'm just gonna add more to show you what it would look like if you overshot. I'm just too good at this. I can't make a mistake even if I wanted to. All right, it looks like our final point is 32.11. That will help us figure out how many milliliters we added. We're just going to add a bunch more and see if we can get it. Yeah, it got a little bit pinker. You all can probably see that. I think there's enough buffers in here that it's not going to get super, 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 super pink. It'll turn like this bright magenta color. I can actually show you what that looks like. Here. This is what it looks like. Yeah, you guys can see that. That is when you've overshot. So that is that very bright magenta that you're seeing. That is too much. Add if we add a little splash of acid, it actually might help clarify the base. There we go. That might help a bit. Let's see. Yeah. So it's a really pretty color, but that is not the right color. So just from doing this right now, my observation I can make is that the pink that I originally saw was really not that much different than what I'm seeing here. So my guess at this lab is not going to give us it's going to be really hard to find the equivalence point for this particular lab. But we can get close. We can get within a reasonable range. But there you go. So I think we should do another trial. And now that I know what I'm looking for, I'm going to try to get it even less pink than I did on this trial. So I'm going to pull that aside. Let me clean this beaker out. I'm just going to pause this for 1 second. I'll be right back. All right. The other thing I just realized is I should have measured the mass of the tablet that I was putting in. That was kind of a mistake, especially because I'm only using a half. Like, what is a half? What does that mean? So our data is not going to be amazing, but just knowing that it's not going to be amazing, sometimes that's half the battle. All right. So once again, crushing another half. We're going to do trial 2. I'm using a slightly bigger beaker this time so that hopefully it will have a greater volume capacity. There's just a little bit of water in there. That's no big deal. Should not be using my fingers, but it's okay. I'm going to do it anyway. Oh, actually, here's something we can do. I forgot with our previous trial. Got it here. Let's just see what its pH is. Oh, it's pretty basic. Okay, so we will know that this trial definitely was an overshoot. So maybe this next one maybe I'll test it along the way. Okay, we need to add some more acid. We're going to add about 40 again. Get as close as we can. Whoa! Just spilled a little bit. Let me grab a paper towel to wipe that up. That is acid. Okay, good. Double check all your labels. Stack of paper towels. So acid, it's definitely dangerous, but at this low of a concentration, I mean, this is like lower than lemon juice. Again, it's not a good thing on your skin, but oh, I got to record the exact volume. Looks like it is 40.09. Let's go with that. That'll work for me. Mix these two together. Swirl this slightly more effectively. A couple drops of phenolphthalein. Good squirts. While we're here, let's throw a pH paper in and just see what we're looking at. Definitely an acid, quite red. That's good. Have to refill this with sodium hydroxide. I used up a whole bunch last time. Okay. All right, so we're going to go for a lot less sodium hydroxide, and I'm going to check it a little bit more often to see if we can get closer to that. The stopcock is closed. I just double checked. I just used my eyeballs. All right, I'm going to try to fill it up a little bit less this time, so I don't have to. Oh yeah, that'll work. We're somewhere between the 6 and the 7. So let me do a quick measurement. Oh, I didn't take a picture last time. We'll take another picture this time. Forgot to take a picture of the end point so you guys could figure out how to measure it yourself. Maybe this one will make you measure it on your own. Oops. Okay. I wrote down what I think it is, or I'm going to write it down. Hold on, let's see it. I'm thinking it's 6.60. It's pretty gosh darn close. Okay, now concentration. The first 10 or so milliliters, I'm just going to kind of rush it in because I know it's going to take at least 10 milliliters. Last time it seemed to take about 30, so maybe I'll kind of rush through the first 10. That's about right there. Oops. Look at that quick stir. I'm not seeing any signs of anything pink, but I've got a lot of pH papers. Let's just dunk one in. Let's see if we're still basic or acidic or something in between. Oh, yeah, it's still kind of pink. I don't know if you guys can see how that pinkish color, but not very pink. So we're getting closer to not being an acid. So let's slow down. I'm going to add like a few more milliliters. Let's see what we think. About there, maybe 1 or 2 more. Okay, still pretty clear. I'm just going to throw a pH paper in again just for fun. Yeah, if you guys were here doing this, I probably wouldn't have to use quite so much pH paper. Oh man, we're pretty close to neutral, according to the paper. So I'm actually going to record this number. I'm going to do it in pencil just off to the side. So that way, if I overshoot, I have a number that I can go back on. It's a great technique with titrations, just to kind of record the numbers as you go. So we are currently at 19.52. So, and we're still looking fairly good. But let's see if we can get just a little bit of pink. I'm going just drop by drop now. Kind of swirling. So far, I'm not seeing any pink. Ooh, maybe just a tiny bit. Oh, maybe my eyes are deceiving me. Let's see. I don't know. All right, we'll throw in a pH paper. Let's see if we can, let's see if it seems like it's gone. It's kind of still in the neutral zone. Maybe I saw a little pink in there. Oh, I don't know. Maybe let's do this reading and then I'll just write this down because it's definitely, oh, we're still, oh, it's starting to get a little bit green. So I'm going to write this number down. This is 29 point, picture one of these. 29 point, oh yeah, 29.5, 6, 7, 7, 7 maybe? Try to get a picture. Phone cameras are not good at this, I tell you. Especially with this weird thing I'm trying to do here. Trying to like focus and hold everything still. Sorry. Oh, I almost had it. Come on, come on, come on, come on. Focus, focus. Oh, I had it just for a second there. Okay, pretty good. Okay, let's see if we can get this just turned a tiny bit pink. Pinkify, pinkify, turn pink, turn pink. Oh, I think I could swear I just saw it. Yeah, there's a little pink in there for sure. Let's see if we've overshot. Yeah, it's a weird lab, but you know, it's okay. Yeah, we're definitely, it's green. So we are definitely past neutral into probably around pH of 8 or so. So that's probably a good place to stop. Didn't quite get as pink. Didn't really get a lot of pink in there, but I think it's a good place. So I'm gonna write down this last number of 30. Oh gosh, let's see if I can see it. That always helps. Okay, 34, 33.54. 33.54. 33.54. Okay. So that's the actual lab part. And now we just need to go into, well, clean up first of all, everything's just going to get dumped on the sink. I'm going to leave this for now. A lot of times if we were doing this in person, other people would have labs to do. But for right now, let's move that out of the way. And let's get into some calculations and start thinking about what was happening in this lab. So let's do it. All right. All right. All right. Cool. So you can see here in my data table, I've written down all of the data we collected. The concentration of HCl before we started was the concentration of the acid itself, which was 0.15 molar. So that's good to know. Data tables need titles. Let me think about a good title for this one. Maybe maybe like titration of HCl antacid solution. With NaOH. It's not the best title I've ever written. It's not super descriptive, but it kind of gets the gist across. Maybe the results table, I'll come up with something better. Okay, so that's all of our data. Procedure, materials should be pretty obvious. Now we've got some room for some calculations. We've got 2 different trials. So let's take a look at our results so we know what we need to actually calculate. So we need to calculate the volume of NaOH added. Oh, here's our results table. This would probably be something like determining acid neutralized by antacid using NaOH titration. Kind of long, but very descriptive. We know exactly what this lab is all about. And my horrible handwriting, love it. Okay, so we need the volume of NaOH added. We need the concentration of the acid after the antacid was added. So I think that one's going to be actually, weirdly enough, the last thing we're going to do. The amount of acid before, we should be able to figure out the amount of acid after. We should also be able to figure out, and the amount neutralized is going to be related to the concentration after the antacid. So a lot of this is really being able to get a good visual and understanding what's going on here. So let's draw some pictures. So we had like a beaker, and it's not the exact order, but it's pretty close. We had a beaker that had some water, and it had approximately 40 milliliters, and of a 0.1, switch to red, pardon me, 0.12 molar hydrochloric acid solution. So at that point, we had some hydrogen ions, and we also had some chlorine ions, but no one really cares about those. But we'll throw them on in anyway. They don't really do anything. They're pretty soluble. They're not going anywhere. Okay, the next thing we added was we added some antacid. So the question now is, what did the antacid do? Well, the volume of the water hasn't really changed. Not that much anyway, maybe a little bit. Hasn't appreciably changed. So once we added the antacid, the idea here is that the antacid turned some of the hydrogen. So actually you use sodium carbonate. It has a, is it calcium carbonate, I believe? Yeah. I can actually show you the reaction. That's aqueous. That's also aqueous. Okay. So what ends up happening here is actually the calcium is dissolved, so it doesn't really matter. We'll just do the ionic part. You end up with HCO3, which kind of immediately, I'm trying to remember how this works. It sort of decomposes and neutralizes it. Either way, it definitely, if nothing else, it gets the hydrogen out of solution. Yeah, it's calcium carbonate for sure. Yeah, I can look that up later. But anyways, it gets the acid out of solution. That's the idea here. So we know that the pH, our litmus paper, let's draw a little piece of litmus paper. I've got a nice color for that. Here's what we know for certain. When we dipped the litmus paper for both of these, it was red both times. So we know, because of that, that it was acidic. So what probably happened was some of the acid was neutralized into water, but not all of it, some of the hydrogen ions. So in my drawing, I'm drawing it as 2 of them. So 2 of them became water, and 2 of them stayed as hydrogen ions. Our chlorines are still in here. And then there was a whole bunch of other gunk in there too, but there you go. Okay, so the next thing that we did was a titration. And we did this with sodium hydroxide, and it was 0.135 molar sodium hydroxide. And we added a whole bunch of that. The volume went up. And the idea behind that is, at least in theory, is that it neutralized the rest of the hydrogen. So we have no more hydrogen left. So our acid was neutralized in 2 different steps. And over here, we tried to get pretty close to it being, we really wanted it to stay the same color, to be pH of 7, that kind of, or that slightly green. I don't know if we 100% achieved it, but we got close. It was not bad. In theory, it should have been that nice kind of just barely green color. We still had a whole bunch of chlorine ions in here. Those never went away, but they just don't do anything. They're just kind of chilling, doing their thing. And then we also had quite a few sodium ions. Let me use purple for sodium. However much was in there from the sodium hydroxide. The volume also went up. So that's kind of what's happening here, is a visual representation of all of that. So let's do some of the calculations. Let me grab some of the data and we can kind of figure this out. So the first thing that we need is the volume of NaOH added. That's really easy. We've got the end volume and the starting volume. So we just need to subtract those. So if we'll just do the math for the first trial. So 32.11 minus 0.89. So we added 31.22 milliliters. You'll notice I didn't put any units here because that's how data tables work. For 22 milliliters added there. Okay, I'm not 100% sure how to answer that question, so let's skip it. Amount of acid before the antacid. So looking back here, this would have been our starting volume of hydrochloric acid and our molarity. We should be able to figure out how many moles of acid we started with. So it looks like 38.0. So here we can calculate that right here. So that's 0.038 liters of HCl. The concentration was 0.15 moles of HCl per 1 liter of HCl. So that is going to give us 0.0057 moles of HCl. So going back to our drawing, 0.0057. That is here. So our starting point was 0.0057 moles of H plus or HCl, either one. So that's our starting concentration. All right, next question. Amount of acid after we added the antacid. So that's what this whole titration was trying to figure out. We're trying to figure out how much acid was here. That is the same amount that was neutralized by all the the sodium hydroxide. So that's where we're going to use that information. So for that, we are going to need our balanced chemical equation, which in this case is HCl plus NaOH, gives us water and NaCl. So it's a 1-to-1 ratio. This is all balanced. So for every 1 mole of sodium hydroxide, it neutralized 1 mole of hydrogen chloride. So we got to figure out how many moles of sodium hydroxide we added. So we can do some quick math on that. Do on the back here. We've got more space. Okay, so it looks like we ended up using 31.22 milliliters, which is 0.0322 liters of NaOH. Its concentration was 0.135 moles of NaOH for every 1 liter of NaOH. Okay, so that's the moles of NaOH. We now need to convert that into moles of hydrochloric acid. In this chemical equation, they are equal to each other. So some stoichiometry. So this is going to be the moles of hydrochloric acid that were actually neutralized by the sodium hydroxide. So that's going to be 0.3122 times 0.135. Oops. Math is hard sometimes. Okay, 0.0042. How many sig figs do we have? What, it looks like 3, so we'll add another decimal. Moles of HCl. Okay, so what that, again, we'll go back, let me bring this down, 421. Okay, so what that is telling us, again, that's how much was neutralized here. So we can figure out that that was how many moles, that was the molarity, or the moles, of H plus after the antacid. Okay. So the next thing we need to figure out is the amount of acid that was actually neutralized. So however much, basically we just need to subtract these two numbers. This is how much we started with, this is how much we ended with. So however much was this, if we just subtract these two numbers, that's going to be how much the antacid actually neutralized, which is pretty cool. So 0.0057 minus that other number, 0.00149 moles of HCl neutralized by antacid. And that's kind of our answer right here. Which was kind of the whole point of this. 0.00149. Okay. And then finally, the concentration of acid after the antacid was added. We actually can figure that out just with this information because that's how much acid was left. It was in 40 milliliters. We didn't really add any water. It might have changed slightly, but I'm not going to freak out about that too much. So for that, all we need to do is take the 0.00421 moles, divide it by 40 milliliters, which is 0.04 liters. So 0.00421 divided by 0.04 is going to be equal to 0.105 molarity. So the actual molarity, the concentration of acid here was 0.105 molar HCl compared to 0.15 over here. So we started off with 0.15, we ended up neutralizing about a third of it. It's not bad, pretty cool. All right, so that's all the calculations, and you can do that for the other trial. You can try it out and see how it goes for you. And then we just have all these lab questions. So which techniques were easiest or hardest, most challenging? In this case, I would say probably the earlier stages of mixing everything together was pretty easy. Titration itself can be difficult. Using a burette takes a lot of practice, and it's a challenging thing to do. But those are some ideas. How effective do we think it would actually be for heartburn? I don't know. It's kind of your opinion. You can think about that. Drawing a series of models is essentially what this is. So you guys can kind of try that out. Maybe yours will look different than mine. And finally, what was the pH of the acid at first and after adding an acid? Well, I'm going to let you all do that. But we've got the concentration of the hydrochloric acid here and here. You should be able to convert that to pH quite easily. So that's kind of titration for you. The only thing we didn't really cover in this is titration curves, and that's a whole nother fun thing. But essentially, for us, oops, and my lights went on, of course. Why would they stay on? pH and volume of NaOH added. It's going to end up looking something like this. This should be, equivalence point should be at pH of 7 because of the type of reaction that we're working with. And the volume for this trial that it took, we decided was something like 31.22. So something like that. That's a titration curve, just to demonstrate what was happening. And actually, we were kind of tracking that a little bit with the pH papers. You know, the first one or one or two I used, well, for the second trial anyway, were pretty red, and then they started to turn kind of green. So we're sort of moving into like this area here. One of the things that's kind of funky about this lab in particular is that this is like the ideal titration curve because we were dealing with this, probably the antacids probably have some buffers in them. We're going to talk more about this AP chemistry later. Is we probably had a non-ideal titration curve. It was probably more slopey like this. So it wasn't quite so defined. It was a little bit more bright purple, just to kind of give you probably a little bit more like this, and then a bit more of like this kind of gentle sloping sort of thing. We'll talk more about that in unit 8. So, all right, I'm going to stop there. I think you have all the information that you need to be able to do this, and this video has certainly gone on long enough. Let me know if you need help, and until next time.